Example 3 is about single period model. In the text of the example, different cost terms are given. We know the disposal cost, the salvage cost, unit purchase cost, and also we know the selling price. And then in part 1 and part 2, we are asked to calculate quantity or quantities for different distribution of the demand. And then in part 3, we need to calculate a disposal cost that would make an order size of 1,500 units the optimal order size. In order to solve questions 1 and 2, we need to maybe know these parts. First, let's see the continuous uniform distribution. If you remember from the previous slide, we had this equation. We have this equation as the equation we needed to solve. So it was different for different distribution of the demand. And here in this example, we have two different distributions. We have uniform distribution and normal distribution. For the uniform distribution, if we solve the equation, we will get a Q star or optimal order quantity equal to this expression that we can see here. And here, A and B are the starting point and ending point of the interval over which the demand is defined. And then we have normal distribution. For the normal distribution, we need the mu, the mean of the demand, and also sigma, the standard deviation of the demand. And if we know these two values, then simply we can use the inverse of the normal distribution. In the Excel, we know it is norm in function, and then for the first argument, we will feed critical ratio and then mu and sigma. So simply we can calculate the order quantity. Now let's go and see how we do the calculations. Okay, we have a selling price equal to 300. We have a purchase cost equal to 120. We have disposal cost equal to 50, and here the salvage value is equal to 0. We will start with calculating shortage cost and excess cost. Shortage cost, if you remember, it was V minus C. So I am putting V minus C here, so I have a shortage cost equal to 180. Then I have excess cost, which was equal to disposal cost plus unit purchase cost or variable cost minus salvage value. So here we have U plus C minus S, and I get an excess cost equal to 170. And then we can calculate critical ratio. We can see the formula just beside this cell. So it is shortage, C shortage divided by C shortage plus C excess. And the critical ratio is 0.51. In the first part of the assignment, we need to find the optimal order quantity for a normal distribution. Mean and standard deviation is given, so I can simply use norm in function to find the optimal order quantity. So the first argument is critical ratio, and then I have the mean and the standard deviation. So optimal order quantity is 1,400 and let's say 8. In the second part, I will do the calculations for a uniformly distributed demand between A and B. And A is 800 and B is 2000. We saw the formulas in the slides, so I will go and use the same formulas here. we can also see the formula just beside this cell. So it is A plus critical ratio multiplied B minus A. So it is equal to A plus critical ratio multiplied by B minus A, and it will give me the optimal order quantity, 1418. Then in the third part of the assignment, we need to calculate a disposal cost that will make an order quantity of 1500 optimal. To this end, we need to solve this equation. Q, we know this Q. It is just simply like what we did here. Here we know the Q. We know A, we know B, but there is some unknowns in critical ratio, and these unknowns are simply here in the U, in the second here in row 27. In row 27, yes, you can see this equation. So we need to solve simply this equation to get the U, and this part is on U. Yeah, calculate disposal cost using this equation.